So my talk today is called Defending an Application Takedown, and it's primarily focused on injection attacks. So we'll kind of get started with a brief introduction myself. I've been working on web services and web applications for the last 5 or 6 years or so, and really the last year and a half I've had a lot of focus on security. And primarily working on an engineering security team, and we're just trying to measure a few things security-wise across our stack. We'll quickly cover our agenda. So for those of you that aren't familiar with what a SQL injection attack looks like or what it is, we'll cover that real briefly just so no one's behind. I'll show you a vulnerable project I created just so you guys can see what it looks like to have a vulnerability. We'll talk about the vulnerability, then we'll do some actual injection and attack that site. And then we'll fix the vulnerability, and then we'll have some action items at the end before some questions. I tried to, and this is, we have some smart developers here, good or bad, however you say that, but I found a couple applications here at Cerner that I wanted to show demo-wise and show like, hey, we've got some teams that maybe have injection attacks. Unfortunately, they were smart, and I wasn't able to attack their sites. So I don't know if they're here. I don't know. I don't see you. John, are you here? No. I don't. Oh, yeah, there he is. John's there, and then, I don't know. Oh, it doesn't matter. Anyways, so they had good sites, they had good protection against it, and a lot of this will come down to awareness is what it'll come down to. So let's look at what SQL injection is. So there's a big, long definition on SQL injection. We don't have time to read that slide, so we're not going to. But what it really comes down to is SQL injection is really just a malicious attack designed to execute some commands on the back end of a database of a poorly designed system or application or service. And there's a nice XKCD slide that really represents this. Bobby's happy up front. And it's really around the idea that in this slide deck, or in this slide right here, you've got a little child that was named Bobby dropped tables, and so he went to school one day, and then he dropped their whole database at school, right? Because they didn't sanitize their input, so they put his name in the record for the school's record, and then they called the parents and said, our data's all gone. What do we do now? So, but it's a good comic. It really represents this well. So as we look forward throughout the rest of the slides and what we're working on with here is I've created a small sample project, and we're going to work. In this case, we've got this users table I've created. And the data that we really care about on this users table are username and first names, last names, and passwords and things of that nature. Nate Shilley asked me earlier, oh, you didn't salt your password, or maybe it was John, I don't remember. Somebody asked me earlier about salting the passwords, and I said, I'm not doing that for this slides because I just want to show that you can look at the stuff, and that's all that matters. So don't worry, I didn't salt them. It's not, nobody's using this thing except for me. If you don't know what salt is, then great. So if we wanted to go get data out of this, we're writing a simple query for that, right? So we select ID, name, from this table where the name is Andy. So we have the select and we have the qualifier. Then we could append on this additional command where or 1 equals 1. That's always going to qualify as true, and we're going to get all the data back. If you had an application that allowed this to happen, you have effectively allowed somebody to attack your application with a SQL injection attack. Okay? So why do you care about this from this perspective? One of the guys I eat lunch with regularly, he told me when I was telling him about this slide that I was going to present on this, he said, why does SQL injection matter? And I said, well, it does because it's consistently in the top of the list for the OWASP top 10 from 2013, 2010, 2017, and it's consistently happening. There's a website out here, they created a Hall of Shame. In this Hall of Shame, it's updated monthly with new attacks that are going out here. You'll see big companies on here like GoDaddy, WordPress, Equifax, McAfee, the election committee 2 years ago, Belkin. Like it's happening to big companies. It can happen to us. It's not hard to do. And so this is why these things matter and why we should care about this stuff. Now, included with the number one slot here isn't just SQL injection. It's other types of injection as well. But SQL injection continues to be one of the top ones alongside that. So. And so the next question that kind of comes up on this is, why does it keep happening? Because you think it's been around long enough, what's going on here? But we, in general, as developers, how many of you guys read your APIs entirely every time you go and develop the thing? We got one hand back there, and he put it down real quick because he realized he was the only one. We just don't read all the API, the entire API, because it's lengthy, right? Like you have a feature functionality, you want to get it moving, and we just don't have time to read everything. So what that means is we don't read these developer guides for security that come along with our APIs. And so these things exist for us to make secure and proper code, but we just don't focus on them because it's just not part of the development ecosystem that we've really concentrated on highly. Has anybody ever, I really want to know this, has anybody ever made a security comment on a code review? So that's a good number. That makes me happy. I gave this talk at not a developer conference, and nobody really probably knew what a code review was. It was a security conference. But those are good comments to make on code reviews, and this should really become a part of our just general awareness as we're doing these things with security. And then we just have this lack of awareness. I mean, if you look at my badge number is 17740. We're at 63,000 probably now. So we have a lot of new people that work here at Cerner, and that includes a lot of new developers. I have 2 new developers on my team. They just have, they don't know what they don't know, and it's not anything that's wrong. It's just stuff that they're new people. We were new once, I was new once, and you have to learn some stuff, and you're gonna make mistakes along the way. And as you listen to some of the talks throughout the day around faults, we're gonna have faults and we're gonna make errors, but we can kind of counteract that by teaching each other and just becoming aware that this is a thing we should care about. And again, this comes back to reading some of the documentation, just making sure we're aware. All right, so enough about that. Let's look at some of the meat of this presentation. So I've got this vulnerable project. I've got a few services. I've got a Rails service that's out there. It's fully fledged out. I went to do the JAX-RS implementation of it, and I realized that I wasn't going to show 2 examples side by side as much because it would just be too much content for this. So it's not in a repo. It's just I literally typed it in Sublime, and I was like, this will work, I promise. And then I just copied and pasted that into here. So we're going to use that same users table that we looked at before. So nothing's changed here, but you kind of have a reference of what we were doing. And then I made a couple endpoints that are available, and this is all Dockerized, so if you go look at that project, you can run this all locally with Docker Compose. It's got MySQL, you can see your data set, it works really well. And you've got injectable users and then not injectable users. So with injectable users, there's a couple parameters that are injectable. So username and first name are both injectable. And if you pull it down, you can do that exact example I just showed a little bit ago. So if we look at this, we've got, we're going to look at the vulnerability itself. So in Rails, the implementation is, so we've got this SQL statement, and you can see we've got our select statement, and we're just going to select everything because we want all the information from the user. And then we've got our qualifier, and in this case, we're just going to say where the ID is equal to the parameter that that was passed into us. And that's not sanitized, okay? So we just took some input from whoever passed it to us, and we just passed it right on into our string, and we made that available. And then at the bottom, we render that JSON by calling our user model. And so whoever passes anything to us can escape. They can start doing whatever they want effectively at that point. We did the same thing with Rails, except I used a different API. You can see here we wrote pure SQL, but here we actually use the where clause as the qualifier. So a lot of developers might think, oh, I'm using the where clause, it's a little safer. But in fact, it's not, because we still didn't sanitize the input, and we didn't parameterize our inputs. So there's a bunch more Rails examples at this site, and I'm not going to go through a bunch of them, but there were a bunch that I didn't know existed, and I was kind of surprised by. In the calculate method, for instance, if you're summing up things using just some generally available helper methods in Rails, there's a handful of things that you can actually have problems with if you don't know they exist. And I was fairly surprised by that. So I would highly recommend going looking at railssqli.org if you write Rails, because I didn't know these things existed. So if we look a little bit at our JAX-RS implementation, again, I just copied and pasted this from some Sublime anyways. And again, very similar. We're going to create a query. It's select, and we've got our qualifier, and then it's not sanitized again. So same kind of situation. Both of these would result in the same vulnerability being exposed, so that if you were to go and try and use the site or use this application, you could expose this vulnerability really quickly. So as we look forward doing this injection, because we want to do this actual attack, we'll do it step by step just so you can kind of see, if you were just trying to tinker and play, what you would do next. We're not going to use any cool tools for this, other than if you call Swagger or Postman cool tools, then we'll use those. But we just have some general knowledge of the API. I told you what it was. If they have a Swagger doc, you can go and learn and read what it is. And then Postman is just a place, if you're not familiar, that you can go and make calls to services or just using CRUD operations. So if I want to go get all the users, I've got my endpoint. So I've got my host, and I've got my port, and then I've got my endpoint. And then in Postman, for those of you who aren't familiar with Postman, that looks big enough. Okay. You can go and send a request out, and I'll get all my data back. Okay. In this case, I seeded the database with 200 users, and they're totally randomized. And you can see I've got 200 of them. That'll be important later when we get to the point where we're actually doing the injection, because you'll see instead of just getting one or a couple of them back, we'll get them all back. So if we want to get one user, we've got the query parameters like I was showing you before. So again, we've got our host, we've got our endpoint, and then we've got our query parameter, so ID or our first name, and those just vary based on what we're trying to get back. So you can see here in Postman, we do the same thing, except we use the ID query parameter. We send the data back, and you can see we just got that single guy, Wilfred Winthizer. It's all randomized data. I found a cool library for randomizing data in Rails. It was pretty sweet. So we get that back, and then we can do the same thing with the first name. So in this case, I know his first name was Wilfred, so we go and call, and we get that one back for him. So that's all great. So now we can look at what it actually takes to do an injection, just like I said, through Postman. So we've got our host, and we've got our endpoint, and we've got our query parameter. We know that query parameter is injectable because I told you it was. So what we can do is we want to add that OR block, and we want to have a true statement that always qualifies as true, right? So in this case, if we pass this in, we would get back all the data, because our qualifier is when the ID is equal to 1 or when 1 is 1. And 1 is always equal to 1 unless you're in some parallel universe, I guess, maybe, where that doesn't exist. So if we pass this into Postman, and you can see I've coded up or written up so it says 1 equals 1, and we hit send, we're going to get that full 200 list back, okay? So you can see I scroll down, and we got the full 200 back. So if we want to do it by first name, we have to do it a little bit differently, because we're dealing with a string instead of an integer, so we have to actually we have to end the quote. So we have a single quote, and so we do quote plus or plus 1 equals 1, and if we go do that, we'll get the same result back, being that we'll get the full 200 list. And you can see the first name and then the addition of that true block effectively. We'll hit send, and then we'll get that full list back. So this is really time consuming for me to go do this, or for you to go do this, or for somebody that's attacking your site to go do this. So when you're talking about defending an application takedown, this isn't what people are doing. But this is a really trivial example, just so that you can kind of understand what the system's doing behind under the covers or behind the scenes. So that, but people are using much more sophisticated tooling for this. So when it comes down to doing an actual injection, they're using automated tools. So when we talk about automated tools, it's the idea of hacker tools. So there's lots of these to pick from. SequelMap is probably the biggest one that I was able to find. It's included with a couple vulnerability library. The particular one's called Metasploit. It's you can't actually use it on the corporate. You can't use Metasploit on the corporate network without getting flagged by enterprise security. So don't do that. You will get an email from them, and they'll say like, "Hey, don't do that." There's a couple of people here at Cerner that have exceptions, and you might be able to get yourself on the exception list. SequelMap seems like it's totally fine, which is, I've been using it for like 3 months now, and nobody's come and said anything to me. So I would highly recommend checking it out and using it if I was constantly doing development, which I am, or testing my team's develop code. So, but it's a console penetration testing tool that is really designed at detecting and exploiting SQL injection flaws. Okay. It supports all major databases, so in this case, for this example, I'm using MySQL, but it works on Postgres, it works on Oracle, it works on the full gambit of databases you could want to use. It can also do user enumeration, so if you have an idea of what the database is and you want to try and attack that database, you can enumerate a set of users and a set of passwords and credentials to try and log in as well, and it'll all be handled by this. And then it supports various different techniques. When I talk about techniques for SQL injection, I'm not going to go into these too much because it's a way bigger talk than this, but it's Boolean-based or error-based, union queries, or time-based, or there's one or two more. And it's super feature-rich. When I pulled up their documentation, which is pretty amazing and really well-maintained, I was surprised at how many features, if you look through all the usage documentation on what you can do with this tool. And so somebody that's trying to attack you and try and take down your application, they're going to be able to do it just with a couple command line options. And again, it's well-written documentation. It's all GitHub, GitHub Wiki. Go read it if you want to know more. So let's go attack this site that I created, okay? So we're going to use Vladimir Putin, and he's attacking some Macs with really frowny faces on them. I don't know why they're frowny, probably because they're really old. For some of you that just started as interns, you probably don't even know what that machine looks like, which is fine. I used to use one in grade school. I mean, there's probably people older than me here that are like, what? That's what you used in grade school? That's really new. Okay. Okay, so let's walk through the steps of this, okay? So we want to find our target. Our first thing is we want to find our target. In this case, we already know what our target is because I told you what it is. But if you didn't know what your target is, you can use the tool, like I mentioned before, with some command line options, and it'll help you identify places to go and inject. I took that out for this slide, or for this presentation. It takes a while for it to enumerate through query parameters and try and find injectable points, but it can do that for you. So in this case, we know ID and first name are both injectable because of what we showed you before. So if we look at SequelMap and what it actually takes to go do this, there's a parameter that's -u. -u is really the parameter for the endpoint that you want to attack. So if we break this command down, we've got SequelMap, which is SequelMap -u is going to be our first block of that command. And then the second block is our endpoint itself. So, and then again, you've already seen what the endpoint is. So let's look at the demo for that. And for all the rest of the demos, on the left side, as you're looking at this, it's going to be a Docker container I have up and running, and it's just the logs. And sorry, I'm clearing them out because I'd forgotten to, and it's okay. Don't worry about it. And then on the right is going to be the command I'm typing in. In this case, since it's the first time, well, I had already been running it a bunch of times, but it's the second set of times I was running it, I called a command called flush session, which effectively just makes SequelMap forget about everything it's done up until now. And then batch accepts all of the user prompt defaults effectively. So if it were to ask me, you know, I found an injectable endpoint, do you want me to continue with this one, or do you want me to go on to a next one? It just accepts the defaults for those cases. So flush session, I'll only use this one time, and then the rest of the time I'll use batch. So if we look at the output just from that command right there, this is what we're going to see. So on the left, you see a handful of the logs from my Rails application, and on the right, you're going to see what the actual tool is doing. And very, very quickly, it's running through, and you can see it's testing a handful of different things. And when we get to the bottom, you're going to see that it sent a bunch of payloads, it used a bunch of different attack methods, and you can see in the info for the logs for the SequelMap tool that the ID parameter it thinks is injectable, and it passed a payload. And then down below, when we get down to the bottom here, what you're going to see is it gives you a whole breakdown. So it used, like I said earlier, it found the ID parameter, it said it was a Boolean-based blind attack, and then here's the payload it actually sent, which you as a developer are never going to know how to send that very easily. It knows because it is a smart tool. And then over on the left, you can look at my logs, and you can see where that actually got passed into my application, and I can see my logs, and very quickly, they were able to find out that ID is injectable. And so then so that gets us to the point where we know we have a success from the ability to be able to inject and attack that with our tool. So we've got the success kid. He's like 20 now or something I saw the other day. And it's really funny, all these memes from kids that when they were little and they got famous. But he's still a success kid. So what do we do now, okay? So we've identified that injectable parameter, and we want to exfiltrate the valuable data, okay? Because just being able to see these things and work with these things, that's not good enough for us. We want to make some money off of somebody, right? We want to sell this data. We want to do something with that. That's what people that are attacking our applications, that are trying to find health records and things like that, they're going to be doing to us on a regular basis. So step 3 is first we got to figure out all the databases that are available on whatever this machine or whatever this underlying service that we're using is. So there's a real quick, simple flag for that. It's --DBS. If we do that, it'll list all the databases if the session user has read access. So we talk about, I use the word if there because this is where we'll talk about the privilege of least, the principle of least privilege, because if we had prevented the user that we have access to this from being able to read these things, either by not giving them root or various other admin privileges, they wouldn't be able to even get this far and they would be halted in their tracks at this point. So we'll talk more about that in a little bit later, but let's say for this case that we made a mistake. The user that we granted access to, if you're a database administrator, you maybe gave additional access on accident. And so now they use this attack command like we saw before, where it's SequelMap -u, the local or the host, the endpoint for that, and then we say, give me all the database tables with that new option, DDBS or DBS. So again, the right, you're going to see the command we're going to type out, and again, like I said, I'm going to remove flush session. It'll cache everything locally, so the attacks run way faster now because it just builds off of what it did before, and it doesn't have to look up anything. You can see it was almost instant that time, and it still used that same parameter for ID, same payload we used before because it has it all cached, but now it listed a whole bunch of databases for me that I can go and start looking at as an attacker and trying to understand what I would care about or what I would want to see. In this case, since I wrote this application, I know the database I care about is called SecureDB. If I was somebody looking at data and I found a database called SecureDB, I would probably go look in there first anyways. The other things may be of some importance, but that's one of the ones where you're going to go look. If there's any database administrators in here, you know wherever the user information is stored at. If it's stored in here somewhere, that might be valuable too. And then on the left, you can see it ran the endpoint and it did a couple things and it loaded data out of there. So the next thing we want to do is, so now that we've displayed the database, we want to display all the tables for that database. So very simple command, it's --tables, super easy. Lists all the tables for a database. We're going to give it -d. So we have our attack command, and our new options are going to be -d. We're going to give it our SecureDB because that's our database we want to attack, and then --tables to actually list out all the tables on that database. So if we go and change this command. And you can see we gave it the new options, and then it printed out a whole bunch of information. So again, it used the same parameter of ID as we used before. It used the same payload we used before. And so very quickly I found that I have this table called users. If you're not familiar with Rails or how Rails kind of works, schema migrations you don't usually care about, and internal metadata you're not going to care about, but users is a table I'm going to care about, especially if I'm trying to figure out how to log into a machine, right? If I'm trying to log into somebody's system. I want to know where that data's at or how to get to that data. So we know users is probably somewhere we want to start with. So step 5 is going to be, let's display all the columns on that table because I want to know what's kind of stuff they're storing there, right? So again, very easy, --columns, list all the columns for the table. We've got our attack command, we've got our old parameters we passed in, and we've got some new ones. So this time we're going to give it -t for users, and then for our users table, and then --columns to give us the columns. So if we run through this one, you'll be shocked to find out it's going to print out all of the columns that are available on that table, and then we can start thinking about what, as an attacker, would we care about. So, sorry, I clicked a lot to try and help you out, but it was slower than I wanted it to be. So if we look through here, you can see we've got some information, but we've got our SecureDB table for database users, and then database is SecureDB, table is users. And then you can see that whole schema that I showed you earlier is now what we're seeing on our console. Again, all running remotely. I'm running this in a Docker container, and then SequelMap I'm running locally on my Mac. So very quickly I was able to find out there's a first name, a last name, a username, a password, various different things that might be valuable to me. So now that we're in there, we want to display that data because if we can get access to that data, then we can start doing malicious things with it. So if we dump it out, it's just --dump. It dumps all of them for the specific columns. So we've got our old attack command and our old options, and then we're going to give it these new options. -c is the columns that they would want to display. So in this case, I just want usernames and passwords, and I want to dump those out because at the end of the day, I just want to log in and start looking at stuff and tinkering around. So if I give it dash username and dash password and dump it out, you can see there's a whole table of usernames and passwords. And that's, I mean, if I wasn't going as slowly as I'm doing, somebody that's attacking your service, your application, could do this in 30 seconds or less in some cases. They could automate this stuff, and this is what penetration testers do, or attackers do on a regular basis, and they can do it very quickly. You can see I got all 200 entries there, so that's the entire table, and there's old Wilfred at the top. So he's got a great password. Again, these are all auto-generated, so they're all really good. It's nice, strong passwords. Okay, so the next thing we can do with this is we can generate a SQL shell and start looking at how to get data out of here or inserting our own data and things like that. So with dash SQL shell, it opens a SQL shell. Immediately, you have access to the whole shell. And this is where it gets kind of crazy, because now you can really start doing things that aren't just getting data out. You can start putting your own data in. So the new parameter is just dash SQL shell. Shockingly enough, we change that, and then it opens up an entire shell for me. And I can go run a select, so I'll just do a select star from users where ID equals 1, and that'll give me Wilfred back, and you can see I've got all Wilfred's information. On the left, it ran some really crazy queries to go do this. It's pretty wild, like what all it went and did. It's way more than I've seen for any of the other ones, and now I've got all that information, and so what we could really do, we did a select, we could start doing inserts. We could create our own users. We create our own data. We can do whatever we want at that point, and then we can really start to take over the system. So it's pretty awesome that that can happen that quickly. I mean, it's bad for developers because we really need to not let this happen. This is bad, but it's pretty cool. When I saw this and how powerful it was, I was pretty amazed. So again, I don't have Metasploit installed on my machine, but if you go do this stuff at home and you want to tinker with it, there's some other cool option called OS shell, OS pwn, and priv-esc. Priv escalation is what it is. And what those are going to do for you is those will actually allow you to get right into the operating system shell, or just take over the actual operating system. And you can really start to do way more malicious things and think about how you're going to move throughout a network. Because up until now, we've just gotten access to SQL, and we can do stuff with SQL. But once you're on a box and you can actually start, issuing commands to a box with privileges, escalated privileges, you can start going to the next box and moving up and down the lateral throughout the stack, finding email servers, finding where you can start sending emails from to and from people. You can start finding other accounts that are compromised. You can find other databases that are stored elsewhere and various other things. And so you can start thinking about how your application is just going to be the single entry point into having the rest of the applications around you taken down. Or, if it's a remote hosted client or something like that, then other applications for other clients getting taken down. So if we want to look at fixing this vulnerability, what's crazy about this to me, and is as much as this happens regularly in the world, the fixes for these things are very simple, and they just don't happen. So in Rails, for instance, it's a matter of just using prepared statements, really, is what it is what they're called. But it's just a matter of using the API correctly, reading the documentation, and making sure you do it. The same thing applies for Java if you're using JAX-RS. There's lots of libraries out here for this stuff, so I'm not going to go into details on all the libraries because that would just take forever. But these prepared statements allow you to pass in options without having a significant amount of overhead to you or doing things. It's just really writing the code the right way. So if we have that and we want to go rerun SequelMap, so we change our endpoint and we're going to use the not injectable users endpoint at this point. So after we've changed our code, and what you're going to see if we change this over to not injectable users and we run that same command we ran up front, oops, sorry, I got water on myself. You're going to see it runs a bunch of things like it did before, except now we got this big red block. And this big red block says, I couldn't find anything that could inject an attack here. Now, this doesn't mean you're in the clear immediately. There's other levels and risky options you can pass in that can really do more malicious things, and you can go from there. And so by no means is it done, but you could start doing way more with this and start tampering with other data and kind of moving and trying different things. So, but just the fact that we've gotten to the point now where we've stopped somebody, and a lot of times what's happening when people are getting attacked or people are doing the attacks is they're looking for the smallest, simplest, quickest way to get into a system. And so if you block them with this and they see this big red thing, they're going to move on to the next thing, and they're going to bypass you and move on to the next thing. So very similar to, we had a data breach recently with Equifax, and if your credit, if your social security number was breached and things like that, if it was breached and you've locked it or you've put a freeze on it, it may be harder for an attacker to go and get that data. And so if you've done that, they may move on to the next guy because the next guy may not have that, and so they can pull that down much, much quicker and much easier. So if we look at some of our action items for this, so the first one really is getting educated. My team has put out a variety of security content. Some of you have seen probably the Application Security 102 content. It's a pretty basic set of content. It's mostly designed around general security principles. But we've also put out another course, it's Application Security 202. And that one's really around the OWASP top 10 and all the different things that go into the OWASP top 10 and how to write secure code to defend against the other 9 of the top 10. And then we hold a meetup regularly every month. It's the third Thursday of every month called Safe KC. And we talk about various things there. And you can come to that and you can learn about different things we have going on or different things we're doing at Cerner to increase our security posture. Also, understanding how to secure coding practices. So understanding the security of your technical stack. So are you writing Rails, are you writing Python, are you writing Java, are you writing whatever libraries you're using, using prepared statements with those libraries. Making sure when you're doing your code reviews, you're looking at security-related things. Static code analysis is actually one of the best and easiest ways to go do this. If you write Rails and you use Brakeman, Brakeman will automatically try and find where you have SQL injection vulnerabilities in your code for you. So you don't even have to think about this, and it's just something that pops up. I believe Fortify has something similar. I don't use Fortify regularly, so I'm hopeful one of you guys maybe can confirm that, but I think it does. Ian's shaking his head yes. So I know some of the other libraries that we use at Cerner may or may not have different static code analysis, but finding static code analysis tools that can actually find these vulnerabilities is really critical to doing secure development. And then testing your application. Like I said, SequelMap you can use on the corporate network as far as I know. Again, somebody come to me if you try to use it and somebody tries to block you, because that would be awesome. Because like I said, I've been using it for like 3 months and nobody's said anything to me. But it's a really powerful tool, and you can really quickly get an understanding of where you're at from a service perspective. And you can use it on old tools, new tools, really anything you have out there today, and start doing it. And it'll really quickly tell you what you have. You can also, one of the comments I got from somebody is like, oh, I use authorization headers and I have an OAuth token so people can't get my data out. You can pass in options that bypass the authorization header. So let's assume in those cases that somebody's taken over a Cerner Central account and they've gotten access to that, now they have an OAuth token. And they can start hitting your service. You can start passing OAuth tokens into SequelMap too and start getting data back and start taking over the database with an authorization token, and everything looks legit. You've tried to protect yourself in the safest ways possible, but there was just a mistake somewhere else in another system that made your system vulnerable. So, okay, so that is all my slides I have. I'm a little early, but that's okay. I'm not sad about that. Maybe you are, but that's okay. But I do have time for questions if anybody has any questions. If you do, just step up to the mic. One guy almost stood up, but I think he was just thinking about leaving. Oh, we got one. Okay.
Would this still work if you weren't select starring? If you just were select to the first column?
Yeah. It just is looking for. So we're not. Are you talking about in the application itself?
Yeah. So what is it about the JSON that you're returning that's giving it that extra info? Like if you were just returning the first name instead of select star, would you still get the database names and stuff?
So what will happen in that case is if you pass it, again, the tool is going to be passing a handful of payloads, and it's just going to be pulling data back, and all it's doing under the covers is looking for one place where it can effectively qualify all of its SQL queries as true. And once it can do one, it has different ways to attack your database and start passing other payloads to get the rest of the data. So regardless of how you built your query, what it's going to do is it's going to build like a nested query almost, and it's going to start pulling back, and the tool is smart enough that it'll just start pulling back way more stuff. And if you go, their source code's really hard to follow because I can't remember what language it's in, but it wasn't a language I was super familiar with, and so just trying to look through it and trying to understand how that stuff all worked was a little more complicated than I could quite grasp for this. But I did get a good generalization that you can pass it almost anything, and it'll pull back regardless of what other fields you ask for. If you just try to get IDs or username or first names, it'll be able to get everything after that. So. Any other questions at all?
Hi, I really enjoyed the talk. Is it assumed that once you have access to like the SQL shell,
yep.
that from there are no barriers to get to like a bash shell or just like the onto the box itself? Yeah.
So that was and again, this is partially my fault because I didn't record the Metasploit part of this. But so you can actually take over the whole entire operating system and get a bash shell and go from there. If you're using Metasploit, again, this one I know will get you flagged on the corporate network, so do it at home on a separate device if you want to. But you can use OS shell, and that'll open up a bash shell or a terminal right from the OS. Again, this is all dependent on the fact that you've set up a user that has too many privileges, and you can even try this privilege escalation feature too, and it'll try to bump your privileges up for a user even if you've tried to lower them. And so, yes, you can do that. It's a little more complicated because you have to use a different suite of tools in combination with SequelMap. But yes, you can. It all runs in Docker too, so you can run that locally. I got away with that one a little longer on the corporate network before they flagged me, so you can try that. Sorry, enterprise security, if anybody's here. Is anybody here from enterprise security? Oh, good. Oh, Satish, you guys want to do this stuff, so that's okay. Okay. Any other questions at all? Okay, cool. All right. Please leave me feedback on my on the presentation. I forgot to mention check-in. I don't know if it actually matters if you check in, but please leave feedback. I appreciate feedback. I've given this elsewhere, and I'll probably give it somewhere else, I'm guessing, in the future. And so any updates and things I can make are super beneficial. Thanks, everybody.